Hello everyone, today we're going to do more solving of equations. Just now we're going to have variables on both sides of the equation. You're going to find that it's very similar to what we've done in the last lesson. So here's an equation, looks a little bit different, obviously because there's an x on the left hand side of the equation and a x on the right hand side. Process is basically the same, except maybe the first step is a little bit different. What you need to do, just like with normal equations, I think, or equations that we did last time, can I simplify anything on each side of the equation? It doesn't appear that I can. So what I want to do is I want to try to get all my x's on the same side, or all my variables on the same side of the equation. So in order to do that, since 5x is positive, I can either subtract 5x to the other side, or since 2x is positive, I can subtract that to the left-hand side. When trying to decide which one to move, it really doesn't matter. You'll get the same answer in the end. I just like to try to keep my coefficients positive, or the number in front of my variable. So I'm going to go ahead and subtract 2x to the other side, because I know then my coefficient for x is positive. If I were to subtract 5x and bring it to the right-hand side, my coefficient would be a -3. Again, that doesn't matter. I just prefer not to work with negatives. So if I simplify, right, I combine my like terms, my x's over here. 5x minus 2x is 3x. I still have this plus 2 is equal to 2x minus 2x. Well, that cancels. I'm just left with that 14. At this point, it's just like what we did last time. You just have a two-step equation. Undo PEMDAS. So I cover up my variable. I undo that last. I move this 2 to the other side by subtracting 2, because the opposite of adding 2 is subtracting. So I get 3x is equal to 12. Just have to undo that multiplication now, 3 times x with division. So I divide by 3, cancel out, so I get x is equal to 4. Again, you can plug that back in to check your answers, which is always a good thing to do. Here's one, a little bit more tricky, but again, still those variables are on both sides. So I know I have to get all my variables on one side. But before I do that, again, I want to see if I can simplify each side of my equation first before I move things around. Notice there's parentheses on both sides, so it tells me I got to do distributive property on both sides. So 2 times 5x is 10x. 2 times a -1 is a -2. It's equal to 3 times x is 3x. 3 times 11 is 33, and it's positive, so I'm going to say plus 33. There's no like terms I can combine on each individual side, so now I got to move stuff around. So you got to think, should I move the 10x or should I move the 3x? Hopefully you're thinking, well, it's probably better to move the 3x, just because then I keep my coefficients positive. Again, it doesn't matter. I just don't like dealing with negative numbers. So I get 10x minus 3x, so 10 minus 3 is 7, so I get 7x minus 2 is equal to, it looks like I'm left with 33. Again, it's nice at this point. I'm just left with the two-step equation, which is what we did before. So I'm just going to cover up my variable. That black splotch is kind of like my thumb that I'm covering it up. So I know I have to undo the subtracting 2 first, so I'm going to go ahead and add 2 to both sides. When I do that, I'm left with 7x on the left-hand side is equal to 35. From here, to get x by itself, I have to undo the multiplication of 7, so I just divide by 7. So I get x is equal to 5, because 35 divided by 7 is 5. So on this slide, I just have kind of the steps that you use when you're solving equations with variables on both sides. Number 1, like we were just talking about, you first just have to simplify both sides. You got to combine like terms or the distributive property, right? That's what you have to do first. Once you've done that, then you got to get your variable terms to one side of the equation. So move all the x's to the left or to the right. It doesn't matter, but again, it's helpful if that coefficient is positive. Then after that, just solve the resulting equation just like normal, using those inverse operations. So just 2 more quick examples, because we're going to look at some weird things that happen when we solve equations that look like this. And we're going to talk about what our solutions mean in these situations. So again, first step, simplify each side. The left-hand side, nothing to simplify, no parentheses, no combining like terms, so I'm going to leave that the same. On this right-hand side, I'm going to do the distributive property, so I get 2 times 5x is 10x, 2 times 6 is a positive 12. So you might notice, gosh, they're the same, right? Something weird's happening. If you don't notice that, that's okay too. Notice if I subtract 10x, right, to move that to the other side, well, 10x minus 10x is 0x, which is just nothing. Same thing over here. So I'm left with 12 equals 12. This means that for our solutions, we have infinitely many real solutions. Infinitely many solutions. That means it does not matter what I plug in for x, it's always going to hold true. So one thing you'll notice, if your variables cancel out, right, our variables, we had no more x's, and you get a true statement in the end, right, 12 equals 12, then our answer is going to be infinitely many real solutions, meaning it does not matter what I plug in for x, it's always going to be true. On the flip side, if I solve this equation here, again, simplifying both sides, the left-hand side is already simplified as much as it can be. The right-hand side, it looks like I can combine like terms. I have m's, negative 3m and a positive 12m gives me a positive 9m plus 5. Just like the last one, when I move my variables to the same side, if I subtract 9m from the left-hand side and do it on the right-hand side, notice, again, my m's cancel out, and I'm left with no variable, but in the end, I'm left with negative 4 equals 5. So since negative 4 does not equal 5, that means that we have no real solutions. That means there's nothing we can plug in for x in order to make our equation true. So whenever, again to recap, whenever our variables cancel out and we're left with a true statement in the end, like 5 equals 5, 7 equals 7, something like that, that means we have infinitely many real solutions. Whereas if our variables cancel and we have a false statement in the end, then that means we have no real solutions. So here is our lesson on solving equations with variables on both sides. As always, shoot me an email if you have any questions.